Hey, physical science. It's Miss Perry. I hope everybody's doing really well. I, as promised, we're going to go over the velocity and acceleration quiz. So I want to go over that with you. The biggest thing I saw on here was some of you were having problems with finding the right formula to use. So we're going to look at that. So let's just go down through the problems. The first one, you have a swimmer who swims 110 meters toward shore in 72 seconds. Okay, so that's looking for distance. Okay, I'm sorry, that's looking for velocity. So you're looking for velocity on there. Now, if you have, sorry, I want to make sure you can see it. If you have your distance is 110 meters, the time is 72 seconds, and so you're going to find velocity. Now the problem has velocity, distance, and time in it. Okay, so you're going to find a formula that has that in there. So we're looking for V is D over T. Okay, you always know you have the right formula if you are using what you were given. Okay, so I wouldn't use a formula that had acceleration in here because it's not what I was asking for, and it doesn't give it to me. So I'm going to use a formula with velocity, distance, and time. All right, so V equals D over T. I'm going to put in your distance is 110 over 72, and that's going to equal to 1.53 rounded meters per second. Okay, so I'm just looking at what I'm given and finding the formula based on that. Okay, so your next one, you want to find the velocity when you have a baseball that's thrown 38 meters in 1.7 seconds. Okay, so we're going to write down our givens. So I think it's always helpful to do that because you can tell what you have so you can find the formula. All right, so it gives me distance is 38 meters, time is 1.7 seconds, and you're trying to find velocity. Okay, so you've got the same formula. You're going to put your distance, which is 38 meters, over time is 1.7 seconds, and that is going to give you rounded 22.35 meters per second. Now, if you rounded higher than that, if you did like a 22.4, I'll take that, but I would like to have 2 digits after the decimal place. Okay, now let's look at the next one. Bring it up. All right, so you have a dog that runs 50 meters in 60 seconds. Okay, so I have that on here. Sorry, that's my email. So I have distance is 50 meters, time is 60 seconds, and I want to find velocity. So that's the same thing. I'm looking for velocity, so that's distance over time. So this can be 50 over 60, and that's going to give me 0.83 meters per second. Now, units are really important. You want to make sure that when you're giving me a number, I know what the number means. I don't know what 0.83 means by itself. I have to know the unit. And I did have a couple of you that didn't do that. You need to make sure you put the units when you give me an answer. I did not count off on the quiz, but I want to let you know now that I will count off on the test. Okay, you must know the units. Now, Miss Perry, how do I know? Look at the rest of the problem. Distance is in meters, time is in seconds, so velocity is in meters per second. Okay? And it's that way all through here. And you'll see in the other problems, it's the same way. So you just need to pay attention to what you're given. Okay, so we've got number 3. Let's go to number 4. It says a cat that outruns the above dog by doing the same 50 meters in 44 seconds. Okay, so we've changed the time because cats are, awesome. And so your distance is 50 meters, time is 44 seconds. So you're doing the same thing, 50 over 44. And that is equal to 1.14 meters per second. Okay? Now, number 5 gave some of you a little trouble. So let's look at number 5. We're finding distance, and I think those are the problems that gave a lot of people problems for the problems, that distance has 2 different formulas. And the rule for that is, if it gives you acceleration, or it asks you for acceleration, you're going to use the problem that has acceleration in it. Okay? Otherwise, you're going to use the one that has velocity. If it doesn't give you acceleration, you don't use the d equals 1/2, and we'll do that later. So for this one, it says a cyclist that travels 5 hours at a velocity of 12 kilometers per hour. So let's look at what I've got written down. You're trying to find the distance because it doesn't give that to you. The time is 5 hours. Velocity is 12 kilometers per hour. So I know if the time is in hours and it's asking for kilometers because it says answer in kilometers, then I've got everything right. Now, I'm trying to find distance, but how do I turn it around? So that's where we have the triangle that I showed you. And you take the base formula and you put it in the triangle where the top of the fraction is up here. Okay, the top of the fraction is right here. So if you're trying to find distance, it's going to be velocity times time. Okay? So distance is velocity times time. And you know that because of the triangle. So your velocity is 12 and your time is 5. So you're going to add those, multiply those together and get 60 kilometers. Okay? Now, so like I said, this is the part that gave y'all a lot of trouble. If you missed anything, this is probably what you missed. All right, so this is how you figure out what formula to use for distance. Now let's go to the next one. Number 6, a wolf that travels 12 hours at a velocity of 9 kilometers per hour. Oops, where's number 6? There it is. All right, so it's trying to find distance. Time is 12 hours. Velocity is 9 kilometers per hour. So it's the same thing. It's going to be velocity. And your velocity is 9 kilometers per hour times time. Okay? So you're going to be multiplying those together. And your distance is going to be 108 kilometers. Okay? All right, so let's go to number 7. All right, so number 7, you are, what does it say? A car that travels 4 minutes at a velocity of 3.5 meters per second, and it's telling you answer in meters. Okay, so let's see what we got. Yes. Okay, double checking my problem. Okay, so you're trying to find distance, and it says answer in meters. Your time is 4 minutes, and your velocity is meters per second, 3.5 meters per second. Now, this one got a couple of people too. If you've got meters and meters per second, your time has to be in seconds. Okay, so this one was a little tricky. You had to figure out how many seconds are in 4 meters. I'm sorry, 4 minutes. So you had to figure that out and use seconds in the equation because it's meters per second. Okay? So you're trying to find distance. Velocity is 3.5. And your time is 240 seconds. Okay? So you're going to end up with your distance is 840 meters. Okay? All right, so let's go down to number 8. We're going to try to find time on these. So number 8, you know that because that's all it gives you. A car is moving 100 kilometers per hour and it moves 50 kilometers. So your answer is going to be in hours. And let's look at that again. Even if it didn't tell you, you have kilometers per hour and you have kilometers. So it's going to have to be in hours. And again, you're using distance equals velocity times time, just like the other ones. So this is going to be D equals 100 times 50. Okay, so D is going to be equal to 0.5 hours. I am doing the wrong formula. I'm sorry, this is looking for time. I knew something didn't look right. Okay, let's do that again. You're looking at time is D over V. Sorry about that. Remember, you have your triangle right here. Time is D over V. I'm sorry about that, guys. I knew that didn't look right. Okay, so you have distance is 50 kilometers over 100 for your velocity. So your time is going to be equal to 0.5 hours. I'm sorry. I wasn't paying attention. Okay. All right, so number 9, let's go down to it. You're looking for time in this one as well. So number 9 says you have a car moving 4 meters per second. That's your velocity. And it's moving 550 meters. So we're looking for time. All right, so you've got time is distance over velocity. So we're going to plug everything in. 550 over 4. Okay? And that's going to be 137.5 seconds. Okay? Because you have to do it in seconds because you have meters per second. Okay? Now let's go down to number 10. All right, so let's look at number 10. You have, what is the acceleration of your car if you can go from rest to 32 meters per second in 8 seconds? Okay, so this is giving you a lot. You're looking at, you have your acceleration, you're looking for that, you don't know what it is. The time is 8 seconds, but the velocity is, you have to find the change in velocity. Now, some of you probably just went ahead and put 32 because it was from 0, and that's fine. If it's not from 0, if you don't have a 0 over here, then it doesn't matter. You have to subtract it. So you've got change in velocity is final velocity minus initial velocity. Don't get them backwards. So your change in velocity is 32 meters per second. Now we have to find acceleration. So if you look at your formulas, acceleration is change in velocity over time. Okay, so we're going to put your change in velocity is 32 and your time is 8 seconds. Okay, so that's going to give you 4 meters per second squared. Remember, acceleration is meters per second squared. And remember that square doesn't mean you're squaring a number. That's just the unit, okay? That is just the unit, but acceleration must have that little squared there. It's not the same as velocity. And when you're looking at problems, make sure you notice that. I think sometimes you assume it's velocity when it's acceleration, and that'll really trip you up. Okay, so let's look at number 11. How far would the car in the previous question have traveled during 8 seconds? So we're looking for distance. Now, we are looking for the distance over here. You have your acceleration is 4 meters per second squared. Okay. And your change in velocity is still 32 meters per second. Your time is 8 seconds. But it is asking you for distance. Okay, so because you have acceleration, not velocity, you're going to use this formula. Okay, and you guys were trying, some of you tried to use this way on up when you didn't have acceleration, and that's going to mess you up. So if you have acceleration, you must use that. Okay, you can't use the other one, the simpler formula, because it doesn't take into account that you're accelerating. So you must use this one. Okay, so let's go with, you've got d equals 0.5, which is the same as 1/2. The acceleration is 4, and your time is 8. Remember, that's squared. Okay, remember you have to square the 8, not the whole thing, but you have to square the 8. So 11 is going to be 128 meters. So you're just multiplying these together. And make sure you square that and don't square the whole answer. Okay, you're just squaring the 8. Okay? All right, let's do number 12. What is the acceleration of a skydiver who started from rest and reaches the speed of 45 meters per second in 4 seconds? Okay, so let's look at this one again. So you're looking for acceleration, you have velocity, okay, and you have your time. So it's going to be A equals change in velocity over t. So this is going to be 45 over 4, and you're going to get, 11.25. And because it's acceleration, it's meters per second squared. Okay? Okay, 13. We have, how long would it take a hawk to stop if he was flying at 8 meters per second and deaccelerated at 3.5 meters per second squared? So you want to know how long it takes it to stop. You don't have to do change in velocity because it's not really giving you its initial velocity. So you're just going to put the velocity straight. All right, so you have your time, you're trying to find that. Velocity is 8 meters per second. Your acceleration is 3.5 meters per second squared. So looking at your formula, you try to find the one that has all this in it. And this is the formula you're going to find. Okay? But you're looking for time. So because of that, time is acceleration over velocity. So that's what you've got right here. Okay? So we're going to put 8 over 3.5, and that's equal to 2.29 seconds. Okay? Now you could have made 2.3. That would have been fine. I would not round that down to 2 because it's just seconds, so let's keep it at a decimal. But you could have said 2.3. Okay, now 14 and 15 got a little confusing. Okay, some of you guys were okay with the A's, but you weren't okay with the B's. So let's look at that. 14 is how fast would a deer be moving if it accelerated at 5 meters per second squared for 4 seconds? Okay, so it's how fast. So you're looking for velocity. Okay, it's giving you acceleration and it's giving you time. So you're going to use V equals A times T. Okay, so your velocity is 5 times 4. Okay, so that's going to be 20 meters per second. Okay, and you're looking for velocity, so there's no squared. Okay, it's just velocity. You don't have the square on there. Okay, now this is where some of you guys got tripped up on the B part. B, how far from its starting point would the deer be after 4 seconds? Okay, so you do have velocity, but you have acceleration as well. So you're going to be using the acceleration distance problem. Okay, so let's write down what we have. You're looking for distance. You have acceleration, so you have to use it. 5 meters per second squared, and then you have time is 4 seconds. Okay, like I said, you have acceleration, you have to use it. So you've got D equals 0.5, the same as 1/2. Acceleration is 5. Time is 4 squared. Okay, that's how you're going to set it up. And 14B is going to be 40 meters. Okay. Now 15 was the same. I think I've got it on another page. So 15 is the same issue. And what speed would a model rocket be moving if it accelerated from rest at 14 meters per second, which is the same thing as 14 meters per second squared, for 3 seconds. Okay, so it gives you acceleration. You've got 14 meters per second squared. Okay, your time is 3 seconds and you're trying to find velocity. So that's going to be your velocity equals acceleration times time again. So your velocity is 14 times 3. And you're going to get 42 meters per second. Okay. Now, 15B, that was trouble too. So let's look at it. 15B, how high would the rocket be from the previous question? Oh, how high would the rocket go? Okay, so you want to find distance. Okay, so you have acceleration, 14 meters per second squared, and you have time. If you have acceleration, you have to use it. Okay, so you're going to use this formula. So you've got D equals 0.5 times A, acceleration is 14, and then 3 squared is your time. Okay, then you're just going to multiply all that together, and you're getting D is equal to 63 meters. Okay, so you guys take a look at this. If you still have questions, please email me or send me a text via Remind, and we can talk about it individually. I will be doing another video on the more recent force equals mass times acceleration worksheet, but I hope you got a lot out of this. So I'll talk to you later. Bye.